Okay, so now we're recording. Just to go through that first example again, we have the function f of x equals 3 times x. When x is equal to 2, we get 6. The opposite of multiplying by 3 is just dividing by 3. And so when we plug the number 6 in for x, 6 divided by 3 gives us 2. So the inverse function basically just flips around the x and the y. Sound okay so far? Okay, so the inverse function undoes what the original function did. So let's think about f of x equals the sine of x. We know that f of pi over 2 is equal to 1. So we want the function f inverse, when we plug in 1, to give us pi over 2. Okay? Make sense so far? Please raise your hand or say something if you have any questions. Okay. We also know that f of 5 pi over 2 is equal to 1. So we would want the inverse function, when we plug in 1, to give us 5 pi over 2. So that means f inverse of 1 would equal pi over 2, and f inverse of 1 is equal to 5 pi over 2 and pi over 2. And that's a problem. Okay? So the function should only have one output for each input. All right? So this isn't a function at this point. So what we're going to do is we're going to restrict the domain so that this actually is a function.
Yeah, that just means.
Okay. So let's take a look at the graphs. So the first graph is just the graph of y equals sine x. And you'll notice that there's several different x's that have the same value of y. So that's the reason that we're getting the inverse up above to not be a function. So what we do is we restrict the domain. So we're going to look at y equals sine x for x between negative pi over 2 and pi over 2. Okay, so that's the red part of the graph in the middle. And then the final graph is just looking at that a little bit more closely. So now we have a new function. We're looking at f of x is equal to sine x, and its domain is the numbers from negative pi over 2 to pi over 2, and the range, that's the y values, everything from negative 1 to positive 1. So since this function is 1 to 1, what does 1 to 1 mean? That means every y has just one x.
Right. Yeah.
It's invertible.
If the whole thing throws up, it might not have been able to write.
Is that okay so far? So this is us, f of x, and there's two different ways we can write it. We can write arc sine x, okay? Or we can write sine inverse. And it has the domain negative 1 to 1. Whoops. Negative 1 to 1. And the range is negative pi over 2 to pi over 2. So notice that the domain and the range just got flipped around.
Yeah.
Okay? And so this is how we're going to define a brand new function. We say y is equal to inverse sine x, or arc sine x, means
Yeah, I need to.
that equals the sine of y, where
Of course, yes.
x is between -1 and, -1 and 1, and y is between -pi/2 and pi/2. Does anybody have any questions so far? Okay, then we're going to go ahead and take a look at the next page. We're going to need to remember this definition, though, of y equals inverse sine x means x equals the sine of y, and what x has to be between -1 and 1, and y has to be between -pi/2 and +pi/2. And I'm going to stop the recording and restart it again, just so that the videos aren't very long.